Hello everyone, welcome to BGP series. BGP, this is day 6 and today I am going to show you loop avoidance mechanism in BGP. So first we will discuss loop avoidance mechanism in iBGP, and then we will discuss loop avoidance mechanism in eBGP, right? So what is loop avoidance mechanism, by the way? If you remember IGP protocols, right? Let's suppose we have three router R1, R2 and R3, right? These are connected together, fine. And suppose here is one prefix, that is 10.1.1.0/24. So R1 will advertise this prefix to R3, right? And then again R3 will advertise this prefix to R2, and then again if R2 will advertise this prefix to R1. So this is loop because R1 is giving update of 10.1.1.0/24 to R3, and now R1 is receiving same update from R2, right? So this is loop, right? So how we will avoid loop in BGP, in iBGP? First we will discuss how we avoid loop in iBGP. Okay, so understand guys, suppose we have three router, right? R1, R2 and R3. Okay, just suppose these three router are connected together, fine. And here I am running network 10.1.1.0/24. Now this router will advertise this prefix to R3 and R2, fine. Just suppose I am using AS 100 over here, 100 over here and 100 over here, because I am talking about iBGP, right? So AS number will be same. Okay, so now this router will advertise this prefix to R3, right? Which prefix? 10.1.1.0/24. Now there is one rule. Rule is this. Rule is, whenever a router will receive a prefix from iBGP neighbor, from iBGP router, then router will never share that prefix with iBGP neighbor. That means if R3 is receiving this prefix 10.1.1.0/24 from iBGP, then R3 will not share that prefix with R2, because this router is also belongs to same AS. So this is iBGP neighbor, iBGP, right? So rule number one is whenever a router receive a prefix from iBGP, router will never share that prefix with iBGP, with other iBGP neighbor, right? So if R3 will not share this prefix to R2, how loop can we create? Never, right? So R2 will advertise this prefix to R3 and R2, 10.1.1.0/24. But R2 will not advertise to R3 because this is iBGP, right? And R3 will also not advertise with R2 because of iBGP, right? So router will always keep in mind that if a router is receiving a prefix from iBGP neighbor, that means router will never share that prefix with their other iBGP neighbor router, fine. Then you might have thinking that if we have three router, suppose like this, R1, R2 and R3, and if I am running network 10.0.0.0/8 over here, right? So if R1 will not advertise this route, okay, sorry, R1 will advertise this route to R2. If R2 will not advertise this prefix to R3, then how communication will happen, right? 10.0.0.0/8, and I am using AS 100 over here, 100 over here, 100 over here. So which type of neighbor will form between R1 and R2? iBGP, and here also iBGP. So R2 will never share the prefix of 10.0.0.0 with R3. Then how communication will happen in upcoming time, right? After 10 to 15 minutes we will break this rule, right? We will break this rule. We will make communication possible between R1 and R3. But for now, keep in mind that if R1 is receiving a prefix from internal neighbor, then router will never share that prefix with other internal neighbor. Okay, so you know how we avoid loop in BGP? Yes, rule is simple. If a router will receive update from iBGP neighbor, then that router will never send that prefix to other iBGP neighbor, right? iBGP neighbor. Fine. Let me talk first about loop avoidance mechanism in eBGP. eBGP, right? How we avoid loop in eBGP. So suppose this is my router, here R1, here R2, here R3, here R4, okay, and suppose I am running network over here is 10.1.1.0/24, 0/24, okay, and here I am using AS100, here I am using AS200, here I am using AS300, or suppose here I am using AS10, 20 or 30. Here I am using 10, here I am using 20, here I am using 30, and here I am using 40, right? Or you can say, okay, let me make you more clear. Suppose I am using AS10 over here, 20 over here, and 30 over here. Fine. So this router is going to advertise this route with their internal neighbor. Yes, because neighbor say between R1 and R2 is iBGP. Here is eBGP, right? Here is eBGP. Okay. So R1 will advertise this prefix to R2 with prefix 10.1.1.0/24, right? But guys, always keep in mind that whenever a router is advertising a prefix with their internal router, that router will never include AS number in update. That router will never include their AS number in update, right? So R1 is not including their own AS number in update, right? R1 is simply advertising a prefix 10.1.1.0/24 without AS number. Fine. Now R2 will advertise this prefix to R3 because here I am using eBGP, right? Here is eBGP. So R2 will include their autonomous system number in update, right? So R2 is advertising 10.1.1.0/24 and AS number is 10. AS number is 10. Now R3 will advertise to R4, right? So 10.1.1.0/24 and R3 will include their own AS number as well. So R3 is receiving 10.1.1.0/24 prefix with AS number 10. So AS number 10 and R3 will include their own AS, right? That is 20. And just suppose there is one more router, that is R5, right? Which is connected to R4, right? And I am using AS number 130 over here, right? So R4 we advertise this prefix to internal router, right? So but this router will not include their own AS number in update, right? So R4 will share update with 10 with AS number 10 or 20, 10.1.1.0/24 with AS number 10 and 20. This router will not include their AS number, right? Because this is internal BGP, iBGP, right? And suppose I have one more router over here, that is R6, and I am using AS number 40 over here, right? So R5 will advertise this prefix 10.1.1.0/24 and AS number will be 10, 20, and this is eBGP, this is eBGP. So this router will include their AS number, right? 30. Okay, and suppose R1 and R6 is connected together, right? Now R6 will again share update to R1, right? And neighborship is eBGP. So eBGP neighbor, that means this router will include their own AS number, right? So 10.1.1.0/24 and AS number will be 10, 20, 30, and the R6 will also include their AS number because R6 is advertising this prefix to eBGP router. So R6 will include their own AS number, that is 40. Now when this router will receive this update, this prefix, router will say there is one AS number which is 10. So whenever a router will receive a prefix from external BGP and they find their own AS number in that update, then router will never accept that update. That update, right? So this is how we avoid loop in eBGP. So rule number 2 is whenever a router will receive update a prefix from eBGP router, right, and router will find their own AS number in update, then router will never accept that update, right? And rule number 1 is for iBGP, if I receive a prefix from my internal router from my iBGP neighbor, then I will never share that prefix with my other iBGP neighbor, right? And rule number 2 is if I receive a prefix from external router from my eBGP neighbor, then I will check autonomous system. If I found my own autonomous system in update, then I will never accept that update, right? So this is how we avoid loop in eBGP, right? Let me show you practically to make you more clear, right? Okay, we will break this rule as well, right? We will break this rule as well, don't worry, but always remember these two rules, right? For iBGP loop avoidance mechanism, internal router will never share that the prefix which received from internal router, right? And rule number 2 is whenever a router receive update from external router and that router will find their own AS number in update, that means that router will never accept that update. Fine. Okay, just suppose we have R1, R2 and R3, 3 router. Okay, 3 router, and suppose I am using AS 10 over here, 20 over here and 30 over here. So here is eBGP, right? And here I am running one network 10.1.1.0/24/24. Once we advertise this prefix in BGP, right? Router will make entry in their BGP table. We had discussed these things in previous video, right? So how this router will make entry in their BGP table, like a star sign and greater sign, that means valid and best, right? This is a valid route and this is a best route. Which route? 10.1.1.0/24, and next hop will be 0.0.0.0, right? So this is best and valid. That means this router will install this route in their routing table as well. In routing table, this router will install 10.1.1.0/24 is directly connected to my fast Ethernet 0/0. Am I right? And now this router will advertise this prefix to R2, right? This R2. Now how R2 will make entry in their BGP table? That yes, definitely this is a valid and best 10.1.1.0/24, and next hop IP address will be 12.1.1.1. I am running 12.1 over here, 12.2 over here, 23.1 over here and 23.2 over here, right? So next hop is 12.1.1.1, and this router will make entry in their routing table as well, This router will install these routes in their routing table as well, that 10.1.1.0/24, and next hop is 12.1.1.1, right? Now this router is reachable to 12.1.1.1, yes, because this is directly connected network, fine. Now R2 will advertise this to R3 as well, right, to R3 as well. So R3 will store this information in their BGP table like this: star valid 10.1.1.1 or 0/24, and next hop is 12.1.1.1. But now guys, understand this route R3 is not reachable to 12.1.1.1. You are getting my point? So whenever router will share prefix with their BGP neighbor, router will modify next hop, right? I am talking about iBGP. I am talking about iBGP. iBGP. This is next hop rule in iBGP. This is next hop rule in iBGP. So rule is whenever router will share a prefix with their eBGP neighbor, with their, sorry, I am not talking about iBGP right now, I am talking about eBGP, right? So whenever a router will share prefix with their eBGP neighbor, router will modify next hop, right? So router will modify next hop over here, yes, next hop will be 23.1.1.1, right? So sorry, not here, here will be 12.1.1.1, here next hop will be 23.1.1.1, right? Okay, let me talk about rule for next hop in iBGP. Okay, so suppose the same scenario, I have three router R1, R2 and R3. Okay, in eBGP it's very clear, whenever router will receive prefix with their eBGP neighbor, router will modify next hop, right? So router will modify. But in iBGP, whenever a router will share prefix with their iBGP neighbor, router will never modify next hop. So now how communication will happen, right? Suppose 10.1.1.0/24, 12.1 and 12.2 over here, right? 23.1 and 23.2. How communication will happen? If this router will advertise this prefix to R2, now R2 will make entry in their BGP table that, okay, route is 10.1.1.0/24 and next hop is 12.1.1.1. For R1, how R1 will make entry in their BGP table? Star greater sign 10.1.1.0/24 and next hop is 0000. That means self-advertised route, right? This is a self-advertised route, fine. Now here 12.1.1.1. Now R2 will share this update to R3, this prefix to R3. Now how R3 will make entry? Star 10.1.1.0/24. Next hop is 12.1.1.1. Here you will not find greater sign. Why? Because 12.1.1.1 is not reachable from R1 and I am using iBGP. I am using AS 100 over here, 110 over here, 10 over here and 10 over here. That means I am configuring iBGP, right? So router will never modify next hop, but next hop 12.1.1.1 is not reachable from R3, right? That means this is, yes, this is a valid route but not best route. That this is a valid route but not best route because a greater sign is missing over here, right? So how communication will happen? You can configure a static routing. You can configure a static routing, right, to make reachable to R3, to make reachable from R3 to 12.1.1.1. Or what you can do, you can advertise this network, right, 12.1.1.0 in BGP, right, this link. But actually we never advertise WAN link in BGP, right? So we will not advertise 12.1.1.0 in BGP, right? We can configure a static routing for that. Once we will configure a static routing, that this router will reachable to 12.1, this route will automatically will be best, right? Will be best, and then this router will store this route in their routing table as well. Okay, now hope is it clear to everyone. If you have any doubt, let me know in comment, right? Let me know in comment. I will make video again. I try to make you understand. I don't know you are getting my point or not, because we are not live, right? This is a recorded session, so you have to inform me you are getting my point or not, right? Let me clear you more with practical. Let me open GNS3, and you can see over here, here is one topology, right? Here is one topology. So in my topology, how many routers are there? 5 routers, right? Router 1 belongs to which AS? AS100. Router 1 belongs to AS100, and router 2, 3, 4, 5 belongs to AS200, right? I am going to configure IP address first. So I will configure IP address as well as BGP. I will configure complete configuration on R1, then I will move to R2, then R3, R4, R5, right? So don't worry. So I am going to configure IP address over here is 12.1, here is 12.2, here is 23.2, here is 23.3, here is 34.3, here is 34.4, here is 45.4, and here is 45.5. okay, and after that I will show you how communication will happen between these two LAN, right? Because by default this is internal BGP, right here. So when this router will advertise, when I will advertise this prefix in BGP, R1 will share prefix with R2, R2 will share this prefix to R3, but R3 will not share this prefix to R4. So we will break the rule, right? Rule is, whenever a router receive a prefix from iBGP router, that router will never share that prefix with their other iBGP router. Okay, so okay, don't worry, I will make you each and everything understand. You will understand each and everything, don't worry. Let me configure first. So let me turn on the device. Okay, let me access to R1. Let me access to R2 as well. R3. I will configure BGP. It will take 3 to 4 minutes, right? So you can skip the video as well if you know how to configure BGP. You can skip to 3 to 4 minutes, right? Okay, now to R1. Configure terminal interface fast Ethernet 0/0. Okay, let me select this now. Fine, right? IP address. IP address is 12.1.1.1 slash value is 24, so 255.255.255.0, and no shutdown. Okay, exit interface fast Ethernet 0/1, no shutdown. IP address is 10.1.1.1 255.255.255.0, right? Router BGP 100. Neighbor is 12.1.1.2, and remote AS is 200. Am I right? Yes. And let me advertise this network 10.1.1.0 in BGP as well. So router BGP 100 and network is 10.1.1.0 255.255.255.0 mask. Fine. let me show you. So IP BGP, yes, there is entry in BGP table, this only a star sign. Okay, just wait for some time, there will be greater sign as well, because this is a valid plus best. Okay, I will show you just after some time again, right? So let me configure R2 first. Go to R2, configure interface fast Ethernet 0/0, no shutdown. IP address will be 12.1.1.2, 255.255.255.0. exit interface fast Ethernet 0/1, no shutdown. IP address will be 23.1.1.2, 255.255.255.0. exit interface fast Ethernet 0/1, no shutdown. IP address, okay, yes, sorry, I configured 12.2 over here, 23.2 over here. Okay, no need to configure. Do show IP interface brief, yes. Now router BGP 200 and neighbor is 12.1.1.1 and remote AS is 100, right? And other neighbor is AS is 200 and other neighbor is 23.1.1.3, right? Do show IP interface brief, yes, fine. So let me show you BGP table. So IP BGP, there is no any entry now, right? Let me show you the neighbor. So BGP summary, yes, two neighbor. So ping 12.1.1.1. I'm able to ping my neighbor, yes. So IP BGP, so still there is no any route, right? Let me check on R1 why this route is not best. Okay, again this route is not best, right? Just wait. So IP interface brief, port is up. So IP route, okay. So IP BGP neighbor, so IP route BGP, definitely there will no any entry. Router BGP 100, right? Network 10.1.1.0, 255.255.255.0 is mask. So IP BGP, yes. Now this is a best and valid, right? So R1 will share this prefix to R2 as well. So IP BGP, right? So this is best and valid. But let me talk about R3. So first let me configure R3. Okay, configure terminal interface fast Ethernet 0/0, no shutdown. IP address will be 23.1.1.3, 255.255.255.0. exit interface fast Ethernet 0/1, no shutdown. IP address will be 34.1.1.1.4. 255.255.255.0, right? Do show IP interface brief. Okay, 3 and 4. Okay, so I have to correct on this interface IP address 34.1.1.3 255.255.255.0. Do show IP interface brief. Now it's fine. Yes. Now let me configure BGP over here. Router BGP 200, right? And let me check on R2 as well. Okay, router BGP 200, definitely fine. 200 and neighbor on R3, neighbor is 23.1.1.2 and remote AS is 200, fine. And other neighbor of R3 is 34.1.1.4, right? Let me configure. Okay, before configuring R4, let me show you BGP table of R3. So IP BGP. So is there any entry? Yes, there is one entry, right? But guys, see, next hop is 12.1.1.1, right? But 12.1.1 is reachable from R3. No, that's the reason why here is greater sign is missing, right? So here is only a star sign. That means this route is valid but not best. So this router will not install this route in their routing table. So IP route, as you can see over here, there is no entry for 10 network. Why? Because this is a valid but not best, right? So router will not install a route which is valid but not best in their routing table. Router will install a routes in routing table which is valid as well as best, right? So okay, we will break this rule, right? But wait for some time. Let me configure R4 first. Configure terminal interface fast Ethernet 0/0, no shutdown. IP address will be 34.1.1.4 255.255.255.0. exit interface fast Ethernet 0/1, no shutdown. IP address will be 45.1.1.4 255.255.255.0. okay, no shutdown. Okay, do show IP interface brief. Yes, IP address is fine. Let me configure BGP, router BGP 200 and neighbor of R4 is 34.1.1.3 and remote AS is 200, right? And other neighbor is 45.1.1.5. fine. Exit. So IP BGP. So there is no any entry in BGP table of R4. Why guys? Actually, when this router will share this prefix, right? So here is eBGP, right? Here is iBGP. Here is iBGP, right? iBGP. So when R2 will share this this prefix to R3, right? So R3 will receive the prefix 10.1.1.0 from iBGP, right? So router 3 will never share the same prefix with their other iBGP neighbor. So R3 will never share this prefix to R4. So that's the reason why there is no any entry in R4, right? You can see. Okay, just wait for some time. Let me configure R5 first. I will show you how to make communication possible between these two LAN. Okay, interface fast Ethernet 0/0, no shutdown. IP address 45.1.1.5, 255.255.255.0. Exit interface fast Ethernet 0/0/1, sorry, no shutdown. IP address is 50.1.1.1, 255.255.255.0. Exit router BGP 200 and neighbor is 45.1.1.4. 4 and remote AS is again 200, right? Fine. Let me show you. So IP BGP, right? So there is any entry? No. So IP, okay, so IP BGP. Is there any entry? No. Size. So IP interface brief, right? So let me configure, let me advertise 50 network in BGP, right? Router BGP 200 and network is 50.1.1.0. Sub mask is 255.255.255.0. Exit. So IP BGP, you can see over here, right? There is one entry in their BGP table. Which network? 50.1.1.0/24, and this network is, this prefix is valid as well as best. So this router will install this route in their routing table as well. So IP route, yes, you can see over here, right? Let me show you on R4. On R4, yes, this is R4. See, so IP BGP. So there is one route at 50.1.1.0/24, which is valid as well as best. That means this router will also install this prefix in their routing table. So IP route, yes, you can see over here, right? 50.1.1.1. AD value is 200 because this router received this prefix from iBGP, right? So IP BGP. But guys, R4 will not advertise this prefix with R3, right? You can see in R3, where is R3? Yes. So IP BGP, there is no entry for 50 network, right? Because R4 will never share an update which received from iBGP to other iBGP neighbor, right? So that's the reason why here is not 50 network, right? And you can see over here in R3 BGP table there is one route, but this route is not present in routing table. So IP route, right? Why? Because this route is not best. This is only a valid prefix. This is only a valid prefix, right? So now what will we do? Let's see what will we do, right? First of all, what we need to do over here is, first of all, here is 10 network, right? Let me show you first. Here is 10 network, right? So R1 will advertise 10 network to R2, right? R2 will also advertise 10 network to R3, but R3 will not advertise with R4, right? Here is 50 network, so R5 will advertise 50 network with R4, but R4 will never advertise with R3, right? Because you know rule number 1, right? So how to break this rule? How to break this rule? To break this rule, or before breaking this rule, let me show you one thing. Which is more interesting here. Here you can see, so run command show IP BGP, and you can see this route is available in BGP table, but this is not a best route. Why this is not a best route? Because 12.1.1.1 is not reachable from R1. So what we can do over here, we can perform a static routing as well. Let me configure a static routing over here. IP route 12.1.1. suppose 0, 12.1.1.0, and subnet mask is 255.255.255.0, and exit interface, let me define exit interface is 0/0, right? Now you can see, so IP BGP, yes, still this route is not valid. Is check routing table of this router, yes, there is route for 2L network, right? But why? Again here is no entry for 10 network. Yes, now you can see over here this route is valid and best, so that's the reason why this route is available in routing table, right? Okay, let me remove a static routing from here, right? So if R3 have reachability to 12.1.1.1, then this route is best as well as valid, right? That means this router will install this route in this prefix in their routing table, right? But if I remove IP route, let me remove a static routing, then you will see again this prefix will removed from routing table, because IP route 2L.1.1.0 255.255.255.0 and fast Ethernet 0/0, no match. Okay, no problem at all. So IP route, guys, is there entry for 10 network? No. So IP BGP, again this route is not a best route, right? Now what we can do, we can advertise this prefix in BGP as well, right? But we never advertise WAN link in BGP, right? We never advertise WAN link in BGP. So what is the next option we have? We have one more option over here, and that is next hop self concept. Next hop self concept tell to R2 that let me show you, router BGP R2 200, right? And neighbor is 23.1.1.1, 23.1.1.13, right? And next hop self command is telling that whenever you will advertise a network to this neighbor, right? Whenever you will advertise a prefix to this neighbor, right? Your next hop, apply next hop IP address is your self interface IP address, Once I will enter this command, right, then R2 will advertise this prefix 10.1.1.0 with exit interface 23.2 with, okay, let me show you. Now go to R2 and let me run this command again. Yes, not working, right? Clear. Let me clear the table, right? Let me clear the table. So if you remember, there was one more message, that is root refresh message. So whenever I will refresh the table, right, so this router will generate root refresh, and they will again make BGP table and routing table. So let me clear the table, clear IP BGP star soft in. This command will use to clear BGP table. Once I enter, right, this router will generate a root refresh message, right? And now check BGP table. Now you can see over here, this route is valid and best, because now next hop IP address is 23.1.1.2. Now next hop IP address is 23.1.1.2, right? Okay, it's fine. This is a rule of self, next hop self, right? You can say next hop self. That means you are telling to router that whenever you will advertise a prefix, advertise prefix with your self interface, right? With your self interface. Exit interface your self interface, right? Because in iBGP, router will never modify next hop address. So you have to configure this command, right? You have to run this command on router. Now let me check on R4. Let me check on R4. So iBGP, yes, still there is no any entry for 10 network, right? There is no any entry for 10 network because R3 and R4 and R2 is in iBGP. So R3 will never share the update which received from an iBGP, never, right? So that's the reason why there is no any entry in R4 BGP table. So what we have to do over here is, let me explain you one more thing over here. Let me explain you one more thing over here, and that is known as what happened? That is known as route reflector. Route reflector. Route reflector is a feature which is used to break the rule. Which rule? Rule of a router is receiving update from internal BGP router will never share that prefix with the other internal BGP, never, right? So to break that rule, we have concept of route reflector. In route reflector, you have to understand about the three types of device. That first one is server, second one is client, and third one is client, right? Guys, English is not my primary language. That's the reason why it's very difficult to explain with you, right? Because many of my followers requested me to make video in English. That's why I'm making video in English. But earlier I was making video in Hindi, and Hindi is more comfortable for me, right? So if I will explain in Hindi, then definitely I will make you each and everything more clear, right? But if you are getting my point, then no problem. That's very nice, right? So suppose this is your router. This is your router. Every router by default, all router as server for themselves. All router by default, all router are server for themselves, right? By default, if I talk about our topology, oh, here is my topology, right? So this router is a server for themselves, this router is a server for themselves, this router is server for themselves, this router is server for themselves, this router is server for themselves. All router are server for themselves. So suppose this is my server, this is a server router, and for this router the neighbor is non-client. The neighbor is non-client, right? Non-client. Okay, I will make you more understand. Just wait. Let me discuss first route reflector. So server, client, and non-client. So whenever a server will receive a prefix from non-client, right, then that server will never advertise this prefix with non-client server. This server, if a server will receive a prefix from non-client, then that server will never advertise this prefix with their neighbor non-client, right? But if a server will receive an update from client, then that server will share that prefix with non-client device, right? If a server will receive update a prefix from non-client device, then the server will share this prefix with client device, right? If a server will receive a prefix from client device, that server will share that prefix with non-client device with, sorry, client device with client device. So only in one case server will not share prefix with their neighbor, when both device will non-client. So server is your router, right? Server is your router. Non-client is also your router, and non-client is also your router. So in my topology, here is 10 network, right? But R3 is not advertising with R4, right? R3 is not advertising that route with R4. Why? Because this is my server and this is my non-client, this is my non-client, right? Every router, all router are server for themselves, right? So this is server for themselves and the neighbor is non-client, right? Neighbor is non-client, like this, right? So what I can do over here is I can configure this device to client, right? Once I configure this device to client, this router will share the prefix with R4, right? Let me show you how to configure first. So where you have to configure route reflect on R3, right? On R3. So let me show you. Go to configure terminal mode, router BGP 200, and neighbor is 34.1.1.4, right? And type route reflector client. Now after running this command, right, neighbor will down and then neighbor will again up, and now you can check the routing BGP table of R4. So IP BGP, you can see over here there is entry for 10 network, yes, but this is not a valid, this is not a best, sorry, this is a valid but this is not a best. So router will not install this prefix in their routing table. So IP route, definitely there is no entry for 10 network. Why this router is not installing this route in their routing table? Because this is not a best route, this is only a valid, right? Because next hop is 23.1.1.2. So R4 is not reachable to 23.1.1.2, right? So what we can do over here is we can configure again, on R3 next hop rule, right? Next hop rule. So let me configure next hop rule on R3. So what I have to tell to R3, that whenever, okay, just let me show you, neighbor is 34.1.1.4, right? And next hop self, you need to write this command. Now let me show you the BGP table of R4. Yeah, it's still not best, so let me clear the table. Clear IP BGP star soft in. Okay, let me show you BGP table. Now you can see, guys, BGP table 23, next hop is 23, still 23. Now let me tell you one more concept, that next hop rule is applicable for only applicable for edge router, only for edge router. Edge router is R2, this is my edge router, so only we can configure on this router, right? That so what we will do, you can't configure next hop self on this router, right? This command is only applicable for edge router, right? So you have to create route map. If you remember route map, we had discussed in CCNP, right? So let me configure route map over here first on R4. So Okay, on R3 it's fine. Yes, let me configure route map on R4. So command to configure route map is route map. Let me give one name, suppose PM, and permit. Right? Permit means all traffic are permit. Set IP next hop IP, set next hop IP is 34.1.1.3. Now let me use this route map in BGP. So router BGP 200 and neighbor is 34.1.1.3. 34.1.1.3. route map PM and direction will be in which direction I want to apply. Now let me show you the BGP table of R4. So IP BGP, you can see over here guys, still there is entry, but this is not a best, because here again the next hop IP address is 23.1.1.2. so now you need to clear the table. Clear IP BGP star soft or in. Let's see. Now next hop is 34.1.1.3 and this route is valid and best. Now this router will install this route in their routing table as well. So IP route. Yes, there is route for 10 network, right? So in the same way you can configure for R5 as well, right? Configure for, first of all let me configure client to R5 so that R4 will share route, so that R4 will share prefix of 10.1.1.0, right? So router on R4 you have to run router BGP 200, neighbor is 45.1.1.5 and route reflector client, right? Now you can see there will be entry. So IP, first of all we need to clear IP BGP star soft in, right? So IP BGP, you can see there is one entry for 10 network, yes, right? But this is not a valid. So again we have to configure route map for next hop IP address, right? Where on R4, right? On R4 we have to configure one route map. So let me configure route map. Let me give name PM or permit. After that set IP next hop, and next hop IP address will be 45.1.1.4. Right? And let me use this route map in BGP. So router BGP 200, and this time direction will be out, right? So okay, neighbor is 45.1.1.5, right? And route map out, route map PM out. Okay, now let me show you the BGP table of R5. So I know video length is going to be long, going to be large, but you can see over here there is one entry. This one I am talking about. This entry, this is best and valid because next hop is 45.1.1.4, right? In the same way we can configure route map for 50 network, right? So in R4 routing table, right, there is route for 50. Yes, so IP BGP, first of all, show you BGP table. Yes, 50 network is valid and best. So this sorter will install this route in their routing table as well. So IP route you can see over here, right? Now, but in R3 routing table, in R3, let me show you. So IP route in R3 routing table, so IP BGP, right? So there is entry, but this is not valid. If I continue, right? So in the same way you can configure for 50, right? You have to make entry in there in the R1, R2, R3 routing table, right, of 50 network, about 50 network. Then you will be able to communicate from here to here. There is nothing, right? So this is this video. Actually in this video you had learn how we avoid loop in BGP, right? How we avoid loop in BGP. So this is all for today, right? If I will configure each and everything over here, then definitely the length of video will be large, right? So it will be more difficult for you to watch, right? So if you have any problem to configure, you can request me in comment. I will configure it again, right? I will configure it again. But if you understand the concept, you can configure it by yourself as well. Okay, fine. Thank you. If you like the video, please hit on the like button. Thank you guys.